What if the myths of the past weren't just stories, but hidden blueprints for scientific discoveries yet to come? Picture this: ancient storytellers sitting by firelight, weaving tales of distant worlds and celestial wonders. Now fast forward thousands of years, and astronomers are uncovering planets beyond our solar system, exoplanets, that bear chilling resemblances to realms described in Norse mythology. It's as if the Vikings glimpsed the cosmos with a clarity we're only now beginning to match. Think about Yggdrasil, the great world tree from Norse lore, its branches stretching across the heavens, connecting 9 realms. Modern science tells us the universe is a vast web of galaxies and planetary systems, intricately linked by gravity, a cosmic tree of sorts. Or take Muspelheim, a realm of fire and molten chaos where giants forged the stars. Today, we've discovered exoplanets so hot they glow like embers, where iron rains from the sky and oceans boil into vapor. Coincidence or something deeper? This isn't just about myth-echoing science, it's about the human mind reaching across time, grasping at truths buried in metaphor. The Norse didn't have telescopes, but they had imagination honed by centuries of observing the night sky. They saw patterns, cycles, and possibilities that modern astrophysics is now confirming. So how did they know? Were these myths lucky guesses, fragments of lost knowledge, or something more profound? Strap in, because we're about to embark on a journey where ancient sagas collide with cutting-edge astronomy, revealing connections so startling they'll make you wonder, did our ancestors see further than we ever realized? At the heart of Norse mythology stands Yggdrasil, the immense ash tree whose roots and branches bind together the entire cosmos. Its trunk rises through the center of existence, while its limbs stretch into the heavens, cradling the 9 realms like celestial bodies suspended in the void. This wasn't just a poetic image, it was a sophisticated model of the universe, one that eerily mirrors our modern understanding of star systems and their orbiting worlds. Take Midgard, the realm of humans, nestled within Yggdrasil's protective branches like a planet sheltered by its star. High above it lies Asgard, home of the gods, gleaming like a golden world perched in the upper reaches of the cosmic tree. Below, the icy realm of Niflheim sinks into the roots, a frozen wasteland that calls to mind distant exoplanets locked in eternal winter. And then there's Alfheim, bathed in eternal light, an uncanny parallel to the hot Jupiter exoplanets we've discovered, scorching close to their suns. But the most striking resemblance lies in the way these realms interact. The Norse didn't see the 9 realms as isolated islands, but as interconnected domains bound by Yggdrasil's roots and branches, influencing one another across vast distances. Sound familiar? Modern astronomy reveals that planets within a star system are linked by gravity, their orbits intertwined in an intricate dance, just as the realms of Norse myth shift and sway with the turning of fate. Even the creatures of Yggdrasil hint at deeper truths. The serpent Nidhogg gnaws at its roots, much like the chaotic forces of gravity and cosmic collisions that shape planetary systems. The eagle perched atop the tree, watching over all, could be seen as a metaphor for a central star, its light governing the motions of the worlds below. Every layer of this ancient cosmology feels less like fantasy and more like a fragmented star map pieced together through myth. What's truly remarkable is how the Norse envisioned these realms not as static places, but as dynamic worlds with their own laws and rhythms, realms of fire, ice, shadow, and light, each a self-contained universe yet part of a greater whole. It's a vision that aligns startlingly well with the diversity of exoplanets we now know exist. Lava worlds, diamond planets, and frozen giants adrift in the dark. Coincidence, or did the storytellers of the North glimpse something profound about the fabric of reality itself? Muspelheim and Niflheim, these 2 primordial realms from Norse mythology, couldn't be more opposite, yet together they paint a picture of cosmic extremes that modern astronomy keeps confirming. Muspelheim, the land of fire and molten rock, where flames lick the sky and rivers of magma carve the land, sounds less like myth and more like the hellish exoplanets we've spotted orbiting distant stars. Take the planet K218b, a world so close to its star that its surface temperature hits a staggering 1,700 degrees Celsius. Here, rock doesn't just melt, it vaporizes, creating an atmosphere of vaporized metals and scorching winds. It's Muspelheim brought to life, a realm where even the idea of solid ground is laughable. Then there's Niflheim, the frozen wasteland where mist hangs eternal and rivers of ice grind mountains to dust. This isn't just poetic gloom, it's a dead ringer for exoplanets like Ogle 2005 BLG 390LB, a world so far from its star that scientists estimate its surface temperature hovers around -220 degrees Celsius. On planets like these, even the air freezes solid, collapsing into glaciers of nitrogen and methane. The Norse imagined Niflheim as a place of stagnation and inertia, where time itself slows, something modern physics echoes when describing the sluggish molecular motion on ultra-cold worlds. What's fascinating is how these two realms aren't just isolated extremes in Norse myth, they're locked in an eternal dance. The sparks from Muspelheim's fires collide with Niflheim's ice, birthing the first life in the form of the giant Ymir. It's a cosmic allegory for the delicate balance of energy and entropy, heat and cold that shapes planetary formation. We see this play out in star systems today, where young planets either roast in their stars' glare or languish in the outer darkness, with only a rare few finding the so-called Goldilocks zone where life can take root. The Norse didn't just guess at these extremes, they encoded an understanding of nature's polarities into their myths. Lava worlds like 55 Cancri E, where entire hemispheres glow with molten oceans, or frozen drifters like the rogue planet PSOJ 317.9224, untethered from any star, drifting through the void. These aren't anomalies. They're part of the universe's grand spectrum, and the Vikings somehow knew. Whether through keen observation of Earth's own volcanic and glacial landscapes, or through some deeper intuition about the cosmos, they mapped out a universe of fire and ice that science is still catching up to. And here's the kicker, these realms weren't just static backdrops in Norse lore. They were alive, shifting, interacting. When the fires of Muspelheim surged, the ice of Niflheim retreated, and vice versa, a push and pull that mirrors the orbital dynamics of exoplanets. A star's flares can scorch a close orbiting world, while a drift in orbit might plunge it into frozen silence. The Norse didn't have equations or telescopes, but their myths captured the essential truth that the universe is a place of violent contrasts, where creation and destruction are two sides of the same coin. So the next time you hear about a new exoplanet discovered in some impossible corner of space, ask yourself, did the sagas see it coming first? Midgard, the realm of humans, nestled like a fragile island between the fire and ice of existence. In Norse cosmology, it wasn't just another world but a precarious balance, suspended in the great branches of Yggdrasil, protected from the chaos beyond by the gods themselves. This idea of a sheltered, life-bearing realm mirrors one of the most profound discoveries of modern astronomy, the habitable zone. That narrow band around a star where conditions are just right, not too hot, not too cold for liquid water, and perhaps life to exist. Think of it like this, the Norse envisioned Midgard as a fortress encircled by an ocean so vast that even the gods couldn't cross it, a world bounded by the serpent Jormungandr, whose coils sealed humanity off from the wild forces of the other realms. Today, we know Earth sits in a similar Goldilocks zone, shielded by its atmosphere and magnetic field from the lethal radiation of space, while just outside our cosmic neighborhood, Venus bakes in a runaway greenhouse effect and Mars lies frozen in arid silence. The parallels are uncanny. The Vikings didn't have the science, but their myths captured a fundamental truth, that life thrives in balance in a delicate middle ground between extremes. And here's where it gets even more intriguing. The Norse didn't just place Midgard in isolation, it was part of a dynamic system. The gods built it from Ymir's flesh, raised its walls from his bones, and used his blood to form the seas. In other words, Midgard was crafted from the remnants of cosmic chaos, refined into order. That's not so different from how planets form today, coalescing from the debris of stellar nurseries, where dust and gas collide until gravity sculpts them into stable worlds. Even the idea of Midgard being connected to the other realms by the Bifrost, the shimmering rainbow bridge, finds an echo in the way exoplanets are linked to their stars by invisible threads of gravity and light. But the real genius of the Midgard myth lies in its impermanence. The Norse knew their world wasn't eternal. Ragnarok, the doom of the gods, would one day swallow Midgard in fire and flood before it could rise anew. Modern astronomy tells us the same story. Habitable zones shift as stars age. A planet might bask in liquid water for 1 billion years, only to see its star swell into a red giant, boiling its oceans away. Even Earth won't last forever. The Vikings understood on some instinctive level that stability is fleeting, that every Eden has an expiration date. So was Midgard just a lucky metaphor, or did the Norse grasp something deeper about the universe's architecture, that life is rare, fragile, and always perched between forces beyond its control? When we look at exoplanets today, like Kepler 442b or TRAPPIST-1e, worlds that might harbor the right conditions for life, we're peering into echoes of that ancient vision. A realm not too different from our own, cradled in the branches of a cosmic tree we're only beginning to map. Asgard, the shimmering realm of the Norse gods, wasn't just a mythical paradise, it was a celestial masterpiece, suspended high in Yggdrasil's branches like a golden world gleaming against the cosmic dark. Its towering halls, said to be forged from silver and gold, sparkled with a radiance that defied mortal understanding. Today, astronomers are discovering exoplanets that echo this celestial grandeur, gas giants and super-Earth wrapped in metallic clouds, their atmospheres ablaze with auroras and swirling storms of molten minerals. Take WASP-76b, a planet so hot it vaporizes iron, where winds carry molten metal across the sky like some twisted echo of Asgard's ever-burning forges. But it's not just the spectacle that links Asgard to these distant worlds. The realm was described as eternally youthful, untouched by time, a trait mirrored in the way gas giants like Jupiter defy aging, their cores remaining hot and dynamic for billions of years. Even Asgard's legendary walls, built to shield it from the chaos of the outside cosmos, find their parallel in the magnetic fields of exoplanets like HTP-7b, which deflect stellar winds and radiation, preserving their atmospheres like divine fortifications. Then there's the Bifrost, the rainbow bridge connecting Asgard to Midgard. It wasn't just a path, it was a conduit of energy, a shimmering artery between realms. Modern science reveals similar bridges in protoplanetary disks, where streams of dust and gas spiral inward, feeding young planets the material they need to grow. Even the concept of Asgard's higher position in the cosmos aligns with how we now understand planetary orbits, where gravity carves out stable niches for worlds to thrive, far above the turmoil of stellar flares or colliding asteroids. And let's not forget the gods themselves, beings of immense power, shaping the fate of worlds. In a way, stars play that role for their planets, dictating their climates, seasons, even their potential for life. Odin's all-seeing gaze, piercing through illusion, isn't so different from the way telescopes like Kepler and James Webb peer into the atmospheres of exoplanets, decoding their secrets from light years away. The more we uncover, the more Asgard feels less like fantasy and more like a prophetic sketch of the cosmos, drawn in fire and starlight. Perhaps most haunting is how the Norse saw Asgard's fate. Ragnarok would consume even this golden realm, tearing down its walls and scattering its gods, a reminder that no world, no matter how glorious, lasts forever. Science tells the same story. Stars die, planets crumble, and orbits decay. Even the most stable exoplanets will one day meet their end, whether ripped apart by tidal forces or swallowed by an expanding star. The Vikings didn't just imagine a kingdom in the sky, they grasped the universe's relentless cycle of creation and destruction, a truth written as much in their myths as in the light of distant suns. Alfheim and Svartalfheim, realms of radiant light and in-kind darkness, couldn't be more different, yet together they reveal another eerie parallel between Norse myth and modern exoplanet science. Alfheim, home of the light elves, was said to glow with an otherworldly brilliance, a place where the very air shimmered like sunlight on snow. Modern astronomers have found planets that mirror this luminous fantasy, like HD 189733b, a cobalt-blue world where silicate particles in its atmosphere scatter light into a perpetual azure haze. Then there's Kepler 7b, a planet so reflective it bounces back more than 50% of its stars, like a celestial mirror floating in the void, much like Alfheim's crystalline spires described in the sagas. But just as light needs shadow to give it meaning, Alfheim's opposite, Svartalfheim, the realm of the dark elves, finds its echo in the exoplanet Tirias 2b, a world so pitch black it absorbs 99% of the light that touches it. Dubbed the darkest planet ever discovered, it's a place of perpetual gloom where even the faintest starlight vanishes into an abyss. The Norse imagined Svartalfheim as a labyrinth of caverns and forges, hidden from the sun's gaze, an apt metaphor for tidally locked exoplanets like WASP 12b, where one hemisphere forever faces its star in scorching daylight, while the other languishes in eternal night. What's fascinating is how these myths didn't just describe static opposites but dynamic interactions. The light elves of Alfheim were said to wield magic that could heal and nurture, while the dark elves of Svartalfheim forged weapons of unimaginable power, two sides of creation itself. Similarly, exoplanets with extreme albedo differences often host violent weather systems where temperature imbalances whip up supersonic winds, carrying heat from day side to night side in a furious attempt to balance the scales. The Norse grasped this duality. Light and dark weren't just states but forces in constant dialogue shaping the cosmos. Even the creatures of these realms hint at deeper truths. Light elves were described as almost ethereal, their bodies woven from something closer to energy than flesh, a startling precursor to how we now understand life might adapt on high albedo worlds, where organisms could evolve to harness reflected light rather than direct sunlight. Meanwhile, the Dark Elves' mastery of underground forges calls to mind extremophiles thriving near hydrothermal vents, life persisting against all odds in the absence of light. The sagas didn't just guess at these possibilities, they encoded a primal understanding of how life might flourish in the universe's harshest corners. And here's the kicker, Alfheim and Svartalfheim weren't isolated. They were part of Yggdrasil's grand design, their fates intertwined with the other realms. Modern exoplanet systems show the same delicate balance. A hyper-reflective planet like Kepler 7b could cool its star's heat, while a light-absorbing monster like Tirias 2b might warp local space-time with its density. The Norse saw the cosmos as a living, breathing network, where every realm influenced the others, a vision science now confirms as planets tug at their stars, shield each other from radiation, or even steal atmospheres in gravitational duels. So were these myths merely poetic opposites, or did they glimpse a fundamental cosmic truth? That light and dark aren't just settings, they're active players in the universe's story, shaping worlds, forging climates, and perhaps even guiding the evolution of life itself. The next time you hear about an exoplanet cloaked in eternal twilight or blazing like a fallen star, remember, the Norse might have painted its portrait centuries ago, hidden in plain sight between the lines of an old saga. Jotunheim, the realm of giants in Norse mythology, wasn't just a land of towering creatures. It was a place of raw, untamed chaos, where mountains crumbled into valleys overnight and storms raged without end. This vision of a world perpetually in upheaval finds unsettling echoes in the exoplanets we've discovered drifting untethered through the void or locked in violent orbital dances. Take the rogue planet SIMP J01365663 plus 0933473, a Jupiter-sized behemoth hurtling through space without a star to anchor it. Its surface, buffeted by eternal winds and cosmic radiation, mirrors Jotunheim's howling blizzards and quaking Earth, a world where stability is foreign and change is the only constant. The giants of Norse lore weren't just inhabitants of this bedlam, they were embodiments of it, their very presence warping the land around them. Similarly, exoplanets like HD 80606b experience such extreme orbital eccentricity that their seasons shift from inferno to ice age in hours. When closest to its star, this planet's surface temperature skyrockets by over 700 degrees Celsius in less than a day, igniting supersonic storms that would make even Thor's thunder seem tame. The Norse imagined Jotunheim as a realm where the laws of nature, bent to primal forces and modern astronomy, keeps finding worlds where physics itself seems to unravel under such extremes. Yet the parallels go deeper than mere spectacle. The giants were said to dwell in Asgard, a fortress at the edge of reality where perception twisted and distances lied. This uncanny distortion finds a chilling counterpart in tidally disrupted exoplanets like WASP-12b, whose atmosphere is being ripped away by its star's gravity, stretching it into a teardrop of molten rock and gas. Or consider the hypothetical Hyperion planets, theorized to spin so rapidly they bulge into unstable, ever-shaping forms. These aren't just chaotic worlds, they're realms where the very fabric of space and time feels malleable, just as the myths described. What's most striking is how the Norse framed Jotunheim not as an aberration, but as a necessary counterbalance to order. The giants' battles with the gods weren't mindless destruction, they were the universe's way of resetting the scales. Modern astrophysics reveals a similar dynamic in planetary systems, where gravitational interactions between worlds can fling some into the darkness while herding others into stable orbits. Without these chaotic forces, solar systems might never achieve equilibrium. The Vikings, it seems, understood a fundamental truth. Chaos isn't the absence of cosmos, it's the crucible in which cosmos is forged. So were they merely spinning tales of frost and fire, or peering into a deeper cosmic truth? When we observe exoplanets like GJ367b, a dense, iron-rich world pulsing with volcanic fury, or the mega-Earth Kepler-10c, where crushing gravity sculpts mountains taller than Everest in years rather than eons, we're witnessing Jotunheim made real. The giants may have been myth, but their realm, a place of relentless transformation and titanic forces, exists in the data of our telescopes, waiting for those bold enough to listen to what the old stories try to tell us. Vanaheim remains one of Norse mythology's most elusive realms, a land cloaked in mist and whispered about rather than seen, home to the Vanir gods who wielded magic so potent it blurred the line between reality and illusion. This enigmatic world wasn't just hidden, it seemed to exist differently, defying the rigid laws that governed other realms. Today, astronomers are uncovering exoplanets that mirror this very mystery, worlds veiled in swirling dust, their surfaces obscured by atmospheres so thick they swallow light whole. Take the planet GJ1214b, a steaming super-Earth shrouded in perpetual haze where the sky might resemble a dense, glowing fog, a near-perfect echo of Vanaheim's misty borders. What's fascinating is how the Vanir, themselves gods of fertility, prophecy, and untamed nature, embodied forces that modern science associates with these cryptic worlds. Their magic wasn't about brute strength but transformation, bending elements to their will. Similarly, exoplanets enshrouded in dust clouds often defy categorization, their compositions shifting as atmospheric layers churn. Consider WASP-17b, a planet with a silicate-rich atmosphere that might rain molten glass, or Kelt 9b, where molecules are torn apart by extreme heat only to recombine into bizarre new forms. These aren't just planets, they're cosmic cauldrons, alchemizing matter in ways that would feel eerily familiar to the Vanir. Even Vanaheim's liminal position in Norse cosmology finds a parallel in exoplanet science. The realm was said to exist somewhere between Asgard's order and Jotunheim's chaos, neither fully stable nor entirely wild. Astronomers now recognize a similar ambiguity in puffy planets like HTP 1b, worlds with densities so low they defy conventional models, hovering between gas giant and super-Earth. And then there's the protoplanet AB Origi b, still forming in a tempest of dust, its fate uncertain, a celestial embodiment of Vanaheim's fluid, half-formed mystique. But the most haunting connection lies in the Vanir's deepest power, foresight. They perceived threads of destiny even the All-Father couldn't unravel. In exoplanet research, we're now peering into the birthplaces of planets' dusty stellar nurseries like the Orion Nebula, where future worlds are little more than spectral ripples in the dark. These nurseries are cosmic oracles, hinting at planetary fates yet to unfold. The Vanir's prophecies weren't mere tales, they were a metaphor for the universe's unfinished symphony, where dust and gravity compose worlds we can scarcely imagine. So was Vanaheim just a poetic placeholder in the Norse imagination, or did its myths encode a truth about the universe's hidden layers? When telescopes like James Webb unveil exoplanets masked by clouds of titanium oxide or methane, worlds where light bends oddly and surfaces vanish into illusion, we're glimpsing realities the Vanir might have recognized. A realm where the solid becomes spectral, the known dissolves into mystery, and the very act of seeing requires not just eyes but vision. Helheim wasn't just a land of the dead, it was a frozen prison, a realm so bitterly cold that even time seemed to slow. The Norse described it as a place of perpetual mist, where rivers of ice carved through valleys of black stone, and the air itself was thick with the weight of silence. Today, astronomers are uncovering exoplanets that mirror this desolate vision, worlds like Ogle 2005 BLG 390LB, where temperatures plummet to -220 degrees Celsius, cold enough to freeze nitrogen solid. This isn't just a scientific curiosity, it's Helheim made real, a testament to the universe's capacity for absolute stillness. What's chilling is how precisely the myths captured the essence of these frozen wastelands. Helheim wasn't merely cold, it was stagnant, a realm where nothing changed, nothing grew. Modern exoplanet research reveals similar environments, planets like TRAPPIST-1H, so distant from their stars that their atmospheres collapse into icy shells, locking away any trace of movement or chemical activity. Even the rivers of Helheim, said to flow with knives and venom, find an eerie counterpart in the ammonia-riddled storms of planets like Gliese 436b, where toxic ice crystallizes in the gloom. The Norse didn't just imagine a generic underworld, they envisioned a specific kind of cosmic grave, one science is now mapping in the void. Yet Helheim's terror wasn't just in its cold, it was in its inevitability. The sagas taught that all souls, save the bravest warriors, would end up there, dragged into the abyss by the goddess Hel herself. This mirrors the fate of rogue exoplanets, cast adrift from their stars by gravitational upheavals, destined to wander the interstellar dark until their heat bleeds away into nothing. The planet PSOJ 317.9224, drifting alone through space, is Helheim's perfect twin. A world without light, without warmth, without hope of reprieve. The Vikings understood that the universe has a pull toward entropy, a slow slide into cold oblivion that even the gods couldn't escape. But here's the twist, Helheim wasn't just a pit, it was part of the cosmic balance. Its icy grip tempered the fires of Muspelheim, just as frozen exoplanets provide critical data on the extremes of planetary formation. When we study a world like Pluto, with its nitrogen glaciers and hazy, sunless skies, we're peering into the mechanics of entropy itself. The Norse didn't shy from this truth. They wove it into their myths, teaching that death was never just an end. It was a necessary counterweight to life's fleeting heat. So when telescopes uncover another frozen rogue, adrift in the dark, remember, the sagas saw it coming. They knew the universe had room for both the blaze of creation and the silence of the tomb. And in that silence, somehow, they found meaning. The Bifrost Bridge wasn't just a dazzling rainbow pathway in Norse myth. It was a cosmic highway, a fleeting connection between realms that shimmered into existence only when the gods willed it. This wasn't mere fantasy. It was a startling premonition of the gravitational bridges and space-time wrinkles modern astrophysics now probes. Picture the Bifrost not as a static structure, but as a dynamic wormhole, a temporary conduit bending the fabric of reality to link distant worlds. Sound familiar? Astronomers today study similar phenomena. Einstein-Rosen bridges, theoretical tunnels through space-time that could, in theory, connect exoplanetary systems light years apart. The Vikings envisioned a bridge that burned with celestial fire to keep giants at bay. Science reveals how traversable wormholes would require exotic matter to stabilize their lethal tidal forces, preventing collapse. Consider the way the Bifrost was described, fragile yet enduring, visible only to those who knew how to look. This mirrors the elusive nature of gravitational pathways in our universe, like the Lagrange points, gravitational sweet spots where objects can hover between celestial bodies with minimal energy. NASA James Webb Space Telescope orbits one such point now, balanced between Earth and the Sun like a modern Heimdall guarding his post. Even more tantalizing are the cosmic filaments, vast, thread-like structures of dark matter that weave galaxies together across the void. These aren't just metaphors, they're the universe's own Bifrost, hidden in plain sight. But the real genius of the Bifrost myth lies in its impermanence. The bridge shattered during Ragnarok, severing the connection between gods and mortals. Here, the Norse stumbled upon another cosmic truth. Wormholes, if they exist, are likely unstable, snapping shut under the weight of their own physics. The same instability governs rogue exoplanets ejected from their system's worlds like B350162, which races through interstellar space at over 500,000 miles per hour, its gravitational ties to its star forever broken. The Vikings understood that connections between realms were precious, precarious, and never guaranteed, a lesson written into the very laws of celestial mechanics. What's most haunting is how the Bifrost's collapse mirrored the fate of real cosmic pathways. When massive stars die in supernova, their gravitational pull warps nearby space-time, potentially creating transient bridges to other points in the universe before collapsing into black holes. Even the bridge's rainbow hue finds a parallel in gravitational lensing, where light bends around massive objects, splitting into spectral arcs that look eerily like fragments of a shattered Bifrost. The myths didn't just describe a bridge, they encoded the universe's habit of offering, then rescinding paths between the impossible. So was the Bifrost pure imagination, or a glimpse of deeper cosmic architecture? When astronomers speculate about civilizations using wormholes to traverse the galaxy, or when they map the web of dark matter threading the cosmos, they're walking the same conceptual road the Norse carved millennia ago. A bridge may have been myth, but the idea that the universe is riddled with hidden pathways, waiting for those bold enough to cross, is science staring back at us through the lens of time. Fenrir, the monstrous wolf of Norse prophecy, wasn't just a beast, he was a force of nature, growing so vast and powerful that even the gods feared he would one day swallow the sun. To prevent this catastrophe, they forged a chain unlike any other, Gleipnir, a binding woven from the sound of a cat's footsteps, the roots of a mountain, and other impossibilities. This wasn't just magic, it was a metaphor for the invisible forces that tether celestial bodies together. The chains that restrained Fenrir mirror the gravitational bonds holding planets in orbit, delicate yet unbreakable, woven from the fabric of spacetime itself. Think of Jupiter, the solar system's own Fenrir, a colossal world whose gravity could have shredded the inner planets if left unchecked. Instead, like the wolf bound by Gleipnir, Jupiter's orbit stabilizes the system, its immense pull acting as a cosmic leash that prevents smaller worlds from careening into chaos. Even the myth's insistence that Fenrir's bonds grew tighter the more he struggled parallels how gravitational forces strengthen with proximity. Take HD 80606b, an exoplanet whose wildly elliptical orbit whips it close to its star, where gravity's grip becomes so fierce it heats the planet's surface to molten extremes. The harder it fights, the more violently the universe reins it in. But the true brilliance of the Fenrir myth lies in its inevitability. The Norse knew Gleipnir wouldn't hold forever. At Ragnarok, the wolf would break free and devour the sky. Modern astrophysics reveals a similar fate for orbiting worlds. Planets too close to their stars face tidal disruption, their atmospheres stripped away like fraying chains. Others, like the doomed planet WASP 12b, spiral inward, slowly consumed by their suns. Even Earth's orbit isn't eternal. Over billions of years, gravitational tugs from passing stars could one day fling us into the dark. The Vikings didn't just tell a story, they encoded a universal truth. All orbits decay, all bonds shatter, and chaos always lurks beyond the fragile order we take for granted. Yet Fenrir's binding wasn't just about restraint, it was about balance. The gods didn't destroy the wolf, they contained him, recognizing his role in the cosmic order. Similarly, gravity doesn't merely imprison planets, it shapes their destinies. Consider TRAPPIST-1, a system where 7 Earth-sized worlds orbit in resonant harmony, their gravitational dance so precise it creates stable, life-friendly zones. Or the way Saturn's moons shepherd its rings, their orbits carving gaps and edges like celestial sculptors. The Norse grasped this duality. Chaos and order aren't enemies but partners, locked in an eternal dance where destruction and creation are two sides of the same coin. So when astronomers study hot Jupiters straining against their star's pull or rogue planets adrift in the void, they're witnessing Fenrir's struggle writ large across the cosmos. The myth wasn't a fairy tale, it was an ancient blueprint for understanding the universe's most fundamental forces, and as we peer deeper into the night, we might finally be learning to read it. Ragnarok wasn't just an ending, it was a cosmic reset, a storm of fire and ice that would consume the 9 realms before allowing them to rise anew. The Norse envisioned mountains crumbling, stars vanishing, and the great wolf Fenrir devouring the sun itself. Today, we know the universe is no stranger to such catastrophes. Exoplanets collide, stars explode, and entire systems unravel in ways that mirror the apocalyptic imagery of the sagas with chilling precision. Take the planet Kepler 107c, a world thought to have survived a catastrophic impact so violent it stripped away its outer layers, leaving behind a dense metallic core, a dead ringer for the charred remains of Muspelheim after Ragnarok's fires burned out. The myth's most haunting parallel lies in its depiction of Yggdrasil shaking to its roots as the realms tear apart. Modern astronomy reveals similar upheavals in binary star systems like V1309 Scorpii, where 2 stars orbit so close they rip material from one another, spawning titanic plasma storms. Or consider the fate of planets like PSRB 1620-26b, a world orbiting a pulsar, the corpse of a supernova where radiation blasts the surface with the same fury as Surtur's flaming sword. These aren't just destructive events, they're transformations, turning order into chaos before birthing something new, just as Ragnarok would give way to a fresh world. Even the timing of the apocalypse feels eerily prophetic. The Norse believed Ragnarok would arrive after 3 winters without summer, a sudden climate shift heralding doom. Exoplanet science shows us worlds like K218b, where runaway greenhouse effects have turned entire atmospheres into furnaces, or glacial planets like Ogle 2005 BLG390LB, frozen in perpetual winter. These aren't static deaths but processes, slow-motion Ragnaroks playing out over millennia. The Vikings may not have known the physics, but they understood the pattern. Collapse precedes rebirth, whether in myth or stellar nurseries where dying stars seed new planets. What's most profound is how Ragnarok's aftermath mirrors the cyclical nature of the cosmos. The sagas speak of two human survivors, Lif and Yggdrasil, emerging from the wreckage to repopulate the world. Astronomy reveals similar resilience, like the planet MOA 2011 BLG 293 LB, a gas giant that survived its star's red giant phase, emerging scarred but intact. Or the debris disks around white dwarfs where shattered planets might reform into new worlds. The Norse didn't just predict destruction, they foresaw the universe's relentless capacity for renewal. So when telescopes capture the remnants of a supernova or the death throes of a star consuming its planets, we're witnessing Ragnarok in real time. The myths weren't exaggerating, they were distilling cosmic truths into stories, reminding us that even the stars must die to make way for what comes next. Skoll and Hati weren't just wolves in Norse mythology, they were cosmic predators, forever chasing the sun and moon across the sky, destined to catch and devour them at Ragnarok. This relentless pursuit mirrors the violent dances of binary star systems, where two stars orbit so close they tear material from one another in a celestial tug of war. Take the star system Beta Lyrae, where one star sucks gas from its companion, creating a swirling disk of superheated plasma as if Skoll himself had taken a bite. Or consider exoplanets like Kepler 16b, orbiting twin suns locked in an eternal chase, their gravity stretching and compressing the planet's atmosphere with each pass, a real-world echo of the wolves' unending hunt. The Norse didn't just imagine this chase as a simple race, they described it as a cycle of near capture and escape where the sun and moon barely outrun their pursuers. Modern astronomy reveals similar rhythms in heartbeat stars, binary systems that pulse with light as they stretch and distort each other, their orbits so tight they nearly touch before swinging apart again. The star system V717 Sagittarii behaves like this. Its two stars locked in a gravitational embrace that sends flares of energy arcing between them, less like wolves and prey and more like partners in a deadly waltz. Even exomoons aren't safe. Theoretical models suggest moons orbiting gas giants in binary systems could be ripped apart by tidal forces, vanishing as suddenly as the moon in myth when Hati's jaws snap shut. Yet the wolves' role wasn't just destruction, it was balance. Without their chase, the Norse believed day and night would lose their rhythm, plunging the world into chaos. Similarly, binary star systems often create stable, habitable zones where planets can thrive, their twin suns acting as gravitational anchors. The planet Kepler 451b orbits two stars in such a zone, bathed in the combined light of its twin suns like a child caught between protective parents. The wolves weren't mindless destroyers, they were forces of cosmic order, their pursuit maintaining the delicate equilibrium that lets life exist. What's most striking is how the Norse envisioned the wolves' final victory. At Ragnarok, Skoll and Hati would swallow the sun and moon, plunging the world into darkness, a prophecy that finds eerie resonance in Black Widow star systems, where a pulsar slowly consumes its companion, leaving behind a cold, dead husk. Or take the doomed planet WASP-12b, spiraling into its star with each orbit, its atmosphere boiling away into the void like light swallowed by jaws of shadow. The Vikings understood a truth science now confirms. Even the brightest lights in the universe are fleeting, and every chase must one day end. Odin's sacrifice is one of the most haunting tales in Norse mythology, the All-Father hanging himself from Yggdrasil for 9 nights, pierced by his own spear, to gain the wisdom of the runes. But this wasn't just a story of suffering, it was a blueprint for humanity's own relentless pursuit of cosmic truth. Think about it. Odin gave his eye to drink from Mimir's well of knowledge, trading literal sight for deeper vision. In the same way, astronomers have spent centuries staring into the void, sacrificing comfort, funding, even careers to decode the universe's secrets. The Hubble Space Telescope, our modern all-seeing eye, nearly became a billion-dollar failure when its mirror flaw blurred the cosmos until scientists risked everything to fix it, much like Odin enduring agony to reclaim clarity. Consider the parallels. Odin didn't seek just any knowledge. He craved understanding of fate itself, the hidden threads weaving reality together. Today's exoplanet hunters chase a similar revelation, the laws governing planet formation, the patterns that might reveal another Earth. The God King hung between worlds to grasp the runes. The Kepler telescope floated in the dark for 9 years, its sensors starving for starlight, to uncover over 2,600 exoplanets. Both quests demanded patience, sacrifice, and a willingness to stare into the abyss until it yielded meaning. Yet the deepest connection lies in what Odin's ordeal reveals about discovery. The runes didn't come freely. They had to be wrestled from the universe, carved into being through pain and perseverance. Science operates the same way. Every exoplanet discovery follows years of false starts, like the early detection of Vulcan, a planet thought to orbit Mercury that vanished under scrutiny. Or the Gliese 581 system, where 3 potentially habitable worlds were later debunked, modern versions of Odin's doubt, moments where the universe seems to taunt us with half-truths before revealing its secrets. And then there's the price. Odin's missing eye wasn't just a wound, it was a reminder that wisdom often costs us our assumptions. When astronomers found WASP 76b, a planet where iron rains sideways, it shattered models of how atmospheres behave. When they observed TRAPPIST-1's 7 Earth-sized worlds, it forced us to rethink planetary packing. Each breakthrough, like each rune, demands we surrender something, a theory, a bias, a comfortable worldview, to grasp a deeper truth. The Vikings understood something we're still learning. Knowledge isn't handed down, it's taken with grit and sacrifice. Odin's suffering mirrors the sleepless nights at observatories, the grant proposals rejected, the public skepticism endured by scientists chasing whispers of distant worlds. His myth whispers a challenge across the ages. How much are we willing to bleed for the next great revelation? Because the universe won't give up its secrets easily. It never has. The Well of Erd wasn't just a mystical spring in Norse mythology. It was the universe's memory, a pool so deep it held the past, present, and future within its waters. The Norns, the cosmic weavers of fate, gathered here daily to carve runes into Yggdrasil's roots, etching the destinies of gods and mortals alike. Today, our telescopes do something eerily similar. The Kepler Space Telescope, staring unblinking into the void for nearly a decade, collected light from distant stars like water drawn from a well, each flicker a rune hinting at unseen worlds. And the James Webb Telescope, with its infrared gaze, peers even deeper, not just reading the cosmos's surface but plunging into its hidden layers, like the Norns divining truths from Erd's shadowed depths. Think about how the ancients described the well. Its waters so clear they reflected not just the skies above but the threads of time itself. Modern astronomy achieves this same clarity through spectroscopy, where starlight splits into rainbows that reveal exoplanets' compositions. When Webb analyzed WASP 96b's atmosphere, it wasn't just collecting data. It was reading the universe's memory, decoding the chemical signatures of a world 1,000 light-years away. The Norse imagined the Norns mixing water from Erd with clay to shape fates. Today's scientists blend light with algorithms to reconstruct planets we'll never touch. Yet the Well of Erd's true power lay in its connectivity. It nourished Yggdrasil's roots, linking all 9 realms through shared knowledge. Our telescopes create a similar web, with discoveries like TRAPPIST-1's 7 Earth-sized planets or the Hysian world K218b stitching together a cosmic tapestry. Each new exoplanet isn't an isolated data point but a thread in the larger story of how planetary systems form, evolve, and perhaps harbor life. The Vikings understood that wisdom wasn't static, it flowed, fed by countless tributaries. Modern astronomy proves them right, with each mission adding to a river of knowledge that reshapes our understanding of the universe. There's a haunting symmetry in how the Norse prophecies echo our own predictive models. They saw Ragnarok not as a single event but as a convergence of forces: a star's death, a serpent's rise, a wolf's hunger. Similarly, astronomers simulate exoplanet climates, tracking how greenhouse gases might boil oceans or how tidal forces could rip worlds apart. The planet TOI 700d, with its possible runaway greenhouse effect, isn't just a scientific case study. It's a glimpse of Earth's potential fate, a rune carved in atmospheric data. The Well of Erd taught that destiny wasn't fixed but woven from countless choices. Our telescopes show us the same truth. Every planet's story is written in the interplay of heat, gravity, and time. Perhaps most profound is how both the Norns and modern scientists confront the limits of their vision. The well's waters grew murky when fate was uncertain, just as our telescopes grapple with exoplanets shrouded in dust or hidden in their star's glare. The Norse didn't pretend omniscience, they acknowledged the shadows at the edges of prophecy. Today's astronomers do the same, candid about the mysteries lingering in Kepler's false positives or the enigmatic dimming of Boyajian's star. The humility is the same, whether drawing from a mythical well or a telescope's dataset. We're all straining to see through the universe's veil, knowing some truths remain just beyond our grasp. So when Webb's mirrors capture light from the earliest galaxies, or when a new algorithm mines Kepler's archives for overlooked worlds, we're not just doing science, we're joining the Norns at the Well of Erd, adding our own runes to Yggdrasil's roots. The medium has changed, but the quest remains, to drink deeply from the cosmos's memory, and in its reflections find our place among the stars. The Norns didn't just spin threads, they wove the fabric of reality itself, their fingers tracing invisible lines that bound gods and mortals to unshakable destinies. Strand by strand, they connected every life, every realm, in a tapestry so vast it mirrored the cosmic web we now know shapes the universe. These mythic weavers understood something profound, that existence is a network of invisible forces pulling and twisting the paths of all things. Today, astronomers map this same web not with thread, but with gravity, the unseen force tethering stars to galaxies, planets to their suns, and moons to their worlds. The Norns' loom was Yggdrasil. Ours is the cosmic structure revealed by telescopes like Hubble, showing how filaments of dark matter stitch the cosmos together in a dance as intricate as any fate. Take the TRAPPIST-1 system, where 7 planets orbit in such precise harmony their gravitational tugs create rhythmic resonances. Each world's orbit a thread plucked, sending vibrations through the entire web. The Norns would have recognized this celestial choreography instantly. Their myth spoke of threads stretching between realms, just as gravity links Earth to the Moon or Jupiter to its Trojan asteroids. Even the way they measured fate, cutting some threads short, letting others stretch into eternity, finds a dark echo in rogue planets like PSOJ 317.9224, severed from their stars and adrift in the void, their gravitational tethers snapped. But the Norns didn't just weave, they intervened. When they tightened a thread, destinies collided. Modern physics reveals a similar agency in gravitational dynamics. A passing star can yank a planet from its orbit, flinging it into deep space or plunging it into its sun. The exoplanet HD 80606b endures this brutal tug of war, its wildly elliptical orbit stretching like a thread pulled taut before violently recoiling, superheating its atmosphere to over 1,000 degrees Celsius in hours. The Vikings imagined the Norns whispering as they worked. These worlds scream their furies across the light years. The real magic lies in how the Norns' threads weren't solitary lines, but intersections, knots where destinies tangled. Gravity weaves the same knots. Lagrange points, those gravitational eddies where objects hover in perfect balance, are the cosmos's own loom shuttles. The James Webb Space Telescope orbits one now, L2, a place where Earth's and the Sun's pulls cancel out, allowing it to peer into the abyss undisturbed. Even more striking are the spiral arms of galaxies, where density waves like the Norn's fingers compress gas and dust until stars ignite in their wake. The threads don't just connect, they create. Perhaps the most haunting parallel is the Norn's final act at Ragnarok, severing all threads at once. Astronomers witness similar unravelings when black holes collide, sending gravitational waves rippling through spacetime, a cosmic shearing of the web itself. Or when galaxies like Andromeda and the Milky Way collide in 4 billion years, their gravitational threads snapping and reweaving into new patterns. The Norns knew a truth we're still grasping, that every bond, no matter how eternal, is temporary. The universe is a loom where warp and weft endlessly dissolve and reform, and we're just beginning to trace the pattern. Thor's travels across the Nine Realms weren't just heroic escapades, they were cosmic expeditions, each quest a metaphor for humanity's own relentless push into the unknown. Picture the thunder god hurtling through the void in his goat-drawn chariot, Mjolnir blazing like a comet in his grip. That hammer wasn't just a weapon, it was the ultimate tool capable of shaping mountains, summoning storms, and even bridging realms. In many ways, Mjolnir mirrors our own cutting-edge spacecraft probes like Voyager, armed with instruments that crack open the secrets of distant worlds, or rovers like Perseverance, its robotic arms scraping Martian soil like Thor striking the Earth to summon springs. The parallels run deeper than spectacle. Take Thor's duel with the giant Hrungnir, a battle so violent it shattered mountains and carved new valleys into the land. Compare that to the cosmic collisions we've observed, like the protoplanet Theia slamming into early Earth, a cataclysm that birthed our moon, or the exoplanet Kepler 107c, its metallic core exposed after a titanic impact stripped away its outer layers. Thor's clashes weren't just epic brawls, they encoded an understanding of celestial violence, the kind that forges planets and tears others apart. Even his famed fishing trip, where he hooked the Midgard serpent, feels like a prophetic nod to our own deep space trawling missions like Osiris Rex, reaching into the void to hook asteroid samples and reel them home. But it's Thor's role as a boundary breaker that resonates most. Time and again, he crossed into Jotunheim, Muspelheim, even the underworld, defying the limits set by the gods. That same defiance fuels our probes as they punch through the heliosphere, like Voyager 1 and 2 venturing into interstellar space, or New Horizons revealing Pluto's frozen plains. Each of Thor's journeys, whether to Utgard's illusory castle or the edge of the cosmic sea, mirrors our own missions into the unexplored. The Parker solar probe grazing the Sun's corona, or Juno braving Jupiter's lethal radiation belts. The hammer's power to open gateways finds its echo in gravitational slingshots, where spacecraft steal momentum from planets to fling themselves deeper into the dark. And let's not forget Thor's greatest trial, retrieving the giant's cauldron, a vessel so vast it could brew oceans. This mythic quest parallels our hunt for exoplanets with liquid water worlds like K218b, where a hydrogen-rich cauldron of an atmosphere might hide vast subsurface oceans. The cauldron wasn't just a prize, it was a source of renewal, much like how the discovery of water on Mars or Europa reshapes our understanding of life's potential. Thor's struggles to lift it, its weight testing even his godly strength, mirror the Herculean effort behind feats like the James Webb Telescope's deployment, its golden mirrors unfolding with nanometer precision in the freezing void. What's truly striking is how Thor's failures were as instructive as his victories. When he disguised himself as Freya to reclaim Mjolnir from the giants, the absurdity of a god playing dress-up underscored a deeper truth: exploration demands adaptability. Our space programs have embraced this same flexibility. Rovers repurposed beyond their lifespans, like Opportunity surviving 14 years instead of 90 days, or Ingenuity's helicopter flights on Mars, a gamble that rewrote the rules of off-world travel. Even Thor's humiliation in Utgard, where he failed to lift a cat that turned out to be the Midgard serpent in disguise, feels like a parable for scientific humility. How often have we misjudged celestial phenomena like the canals of Mars or early exoplanet detections, only to realize the universe was hiding its truths in plain sight? So was Thor just a muscle-bound deity swinging a hammer, or did his myths encode a blueprint for the explorer's mindset? When SpaceX lands boosters on drone ships, modern versions of Thor's goat chariot touching down after a sky-spanning journey, or when Artemis aims to return humans to the moon, we're not just advancing technology. We're retracing the thunder god's steps, wielding our own Mjolnirs to crack open the cosmos, one realm at a time. Loki, the shape-shifting trickster of Norse myth, didn't just play pranks, he unraveled the very fabric of order, turning certainty into chaos with a flick of his silver tongue. His antics weren't just entertainment, they were cosmic wildcards, reminders that the universe thrives on unpredictability. And when we look at the strangest exoplanets discovered, it's as if Loki's fingerprints are smeared across the cosmos. Take rogue planets like SIMP J013656663 plus 0933473, untethered from any star, drifting through the void like a trickster slipping between realms. These nomadic worlds don't follow the rules, they're free agents, blazing their own trails through the dark, much like Loki himself vanishing into the shadows just as the gods think they've caught him. Then there's the sheer audacity of planets like HD 80606b, whose orbit isn't just elliptical, it's a roller coaster. This world doesn't circle its star neatly. It dives close enough to scorch its atmosphere, then swings back out into the frozen deep, a temperature swing of over 700 degrees Celsius in mere hours. It's the celestial equivalent of Loki swapping places with Thor at a feast. One moment the room's roaring with laughter, the next chairs are shattered and the mead halls in flames. The Norse believed Loki's disruptions kept the gods from growing complacent. These erratic exoplanets do the same for astronomers, forcing us to rewrite models of planetary formation every time we find another cosmic rebel. But Loki's chaos wasn't just destruction, it was transformation. When he engineered the theft of Thor's hammer or the cutting of Sif's golden hair, he ignited chains of events that reshaped the realms. Similarly, chaotic exoplanets can birth new order. Consider Tatooine worlds like Kepler 16b, orbiting two stars in a precarious dance. Their unstable gravity should tear them apart, yet they persist, their orbits stabilizing over eons into something harmonious. It's the trickster's paradox. What seems like madness might just be the universe's way of innovating. Even Loki's most infamous act, the murder of Baldur, led to the hardening of the gods' resolve before Ragnarok. Likewise, cataclysmic collisions between exoplanets, like the one thought to have stripped Kepler 107c down to its metal core, can forge entirely new classes of worlds. The most Loki-like phenomenon of all, pulsar planets. These worlds orbit the corpses of dead stars, bathed in lethal radiation that should sterilize them, yet they endure, defying expectations like the trickster surviving every execution attempt the gods devised. PSRB 1257 plus 12b, a planet made of solid diamond, shouldn't exist at all. Its star's supernova should have vaporized it, but there it gleams, a celestial prankster grinning from the grave. Even Loki's shapeshifting finds its mirror in Chthonian planets, gas giants like Korot 7b, stripped of their atmospheres by stellar winds until only their rocky cores remain, transformed beyond recognition. Yet for all his chaos, Loki was bound literally when the gods wove his son's entrails into chains. The universe has its own way of restraining its tricksters. Hot Jupiters, those giant planets hugging their stars recklessly close, eventually spiral inward to their doom, consumed by the fires they taunted. Rogue planets, for all their freedom, drift into the abyss, their heat bleeding away into eternal frost. The Vikings understood that chaos and order are locked in an eternal dance, each needing the other to give the universe its texture. So when telescopes spot a planet orbiting backward or a star with rings of debris from some ancient planetary smash-up, we're not just seeing anomalies. We're witnessing Loki's legacy, the glorious, destabilizing spark that keeps the cosmos from ever growing stale. The Valkyries weren't just celestial escorts, they were cosmic curators, sweeping across battlefields to pluck the finest warriors from the carnage and carry them to Valhalla. This act of divine selection wasn't arbitrary. It was a meticulous filtration, ensuring only those worthy of Odin's army would shape the fate of the cosmos. Strikingly, the universe operates on a similar principle when it comes to exoplanets. Just as the Valkyries sifted through countless souls to find the elite, nature sifts through countless worlds to find those rare few where the conditions for life align perfectly. Think of Earth as one of the chosen, a statistical outlier where temperature, atmosphere, and chemistry converge to create a cradle for biology. Consider the Valkyries' criteria: strength, courage, the ability to endure the impossible. Habitable exoplanets must meet their own brutal standards. Too close to their star and they boil away like Surtur's flames, too far and they freeze into Niflheim's silence. Only in the narrowest of bands, the so-called Goldilocks zone, do planets avoid these extremes, much like warriors who navigated the chaos of battle to emerge unscathed. Even then, stability isn't guaranteed. The Valkyries sought warriors who could adapt to Valhalla's eternal battles. Exoplanets must withstand stellar flares, gravitational upheavals, and the slow erosion of time. TRAPPIST-1e, a rocky world nestled in its star's habitable zone, isn't just lucky. It's resilient, its orbit steady despite the gravitational tug of 6 sibling planets. Yet the Valkyries didn't act alone. Odin guided their choices, his one eye piercing through illusion to foresee which warriors would tip the scales at Ragnarok. Similarly, exoplanets don't exist in isolation. Their stars play the role of cosmic overseers. A quiet, stable star like our Sun fosters life, while a tempestuous red dwarf bathes its planets in lethal radiation, stripping away atmospheres like a battlefield claiming the unprepared. Kepler 186f, a planet orbiting a calm M-dwarf star, might be one such chosen world, its star's gentle light offering a refuge amid the chaos of the cosmos. What's haunting is how the Valkyries' selections weren't permanent. Even in Valhalla, the chosen faced their final test at Ragnarok. Exoplanets too exist on borrowed time. A star's evolution can turn a paradise into a wasteland. Just as Earth will one day roast under the sun's expanding glare, the Viking mind grasped this impermanence. Their myths didn't promise eternal reward, just a chance to fight for something greater. In the same way, habitable exoplanets aren't eternal sanctuaries. They're temporary arcs, their windows for life opening and closing with the unforgiving precision of a Valkyrie's sword stroke. Perhaps the most profound parallel lies in the randomness of selection. Not every great warrior made it to Valhalla. Battles are chaos, and even the worthy could be overlooked. The universe is no different. For every Earth, there are countless near misses. Worlds like Venus, a hair too close to the Sun, or Mars, a whisper too small to hold its atmosphere. The Valkyries' choices felt divine, but they were bound by the phrase unpredictability. Exoplanet habitability, too, is a dance of chance and physics, where minuscule shifts in orbit or composition separate flourishing biospheres from barren rock. So when we scan the skies for another pale blue dot, we're not just hunting for planets. We're replaying the Valkyries' saga on a cosmic scale, searching for the rare, the resilient, the chosen. Worlds that, against all odds, hold the right to host life's fragile flame. And in that search, we might finally understand how thin the line is between a battlefield's chaos and a hall of heroes. Heimdall stood at the edge of the worlds, his golden gaze piercing the mist between realms, never sleeping, ever watchful. In Norse myth, he was the ultimate sentinel, perched at the rainbow bridge Bifrost, attuned to the faintest tremors of approaching chaos. Today, our telescopes fulfill that same sacred duty, scanning the cosmic horizon for whispers of distant worlds. Like Heimdall's supernatural hearing, which could detect grass growing on Midgard or frost forming in Niflheim, instruments like the James Webb Space Telescope catch the faintest infrared murmurs of exoplanets light years away, translating starlight into revelations. What's uncanny is how closely Heimdall's attributes mirror modern observational tech. His eyes, said to gleam with the brilliance of the sun itself, reflect the adaptive optics of observatories that counteract atmospheric distortion, sharpening blurry stars into crisp points ripe for planetary detection. His horn, Gjallarhorn, wasn't just an alarm, it was a resonant instrument vibrating across dimensions. Similarly, radio telescopes like Alma tune into the universe's frequencies, catching the faint radio songs of protoplanetary disks where worlds are born. Even Heimdall's foresight, the ability to anticipate threats before they arrived, finds its parallel in predictive algorithms that sift through terabytes of data, flagging the subtlest stellar wobbles that betray an exoplanet's presence long before human eyes spot the pattern. Consider the TRAPPIST-1 system, 7 Earth-sized planets dancing around a dim red star, their orbits so precise they create gravitational harmonies. Heimdall would have recognized this celestial clockwork instantly. His myths describe him perceiving the threads of fate woven through Yggdrasil's branches, not so different from how astronomers track orbital resonances, calculating how planets tug one another into rhythmic stability. Or take the way he guarded Asgard's borders against giants. Modern telescopes like TESS patrol vast swaths of sky, their lenses serving as digital ramparts against the unknown, spotting giant exoplanets that could upend our models of planetary formation. Yet Heimdall's true power lay in his synthesis. He didn't just see, he interpreted. A rustle in Jotunheim might signal an approaching frost giant. A flicker in starlight reveals a transiting planet. The Hubble Deep Field images, revealing thousands of galaxies in a patch of sky no wider than a grain of sand held at arm's length, demonstrate this same transcendent vision. Like Heimdall surveying all 9 realms at once, these telescopes collapse cosmic distances into comprehensible frames, revealing patterns invisible to mortal eyes. And then there's Ragnarok. Heimdall's final act, blowing Gjallarhorn to herald the end of times, mirrors the alarm raised by discoveries like Kelt 9b, a planet so scorched by its star it's literally evaporating. Such finds are our own Gjallarhorn blasts, warning that even seemingly stable worlds face eventual doom. The Watcher's duty wasn't just observation but vigilance, a call we've heeded by monitoring exoplanet atmospheres for signs of cosmic upheaval, from runaway greenhouse effects to the slow death spirals of tidally locked worlds. Perhaps the most profound connection lies in Heimdall's origin. Born of 9 mothers, nourished by the Earth's strength and the sea's depth, he embodied multiplicity, a fitting metaphor for how modern astronomy synthesizes data from spectrographs, photometers, and coronagraphs to assemble a coherent portrait of distant worlds. The god's piercing sight wasn't innate, it was earned through connection to the fundamental forces. Our telescopes, too, are collective achievements, built on centuries of accumulated knowledge, each break through a stepping stone toward sharper vision. So when Webb's mirrors focus on an exoplanet's atmospheric spectra, or when TESS catches the dimming of a star, we're not just collecting data, we're channeling Heimdall's legacy. The Watcher's vigil endures not in myth now, but in silicon and steel, his golden gaze reborn as pixel and algorithm, forever scouring the cosmic shores for whatever truths or giants may come. The mead of poetry wasn't just a mythical drink. It was the essence of divine inspiration, a golden elixir that transformed those who drank it into seers and skalds, capable of weaving reality into verse. But what if this mead wasn't just a metaphor for artistic genius, but for the very act of scientific discovery? Picture the mead's creation. Odin, in a relentless quest for wisdom, infiltrated the mountain stronghold of the giant Suttungr, risking everything to steal the knowledge hidden within. Doesn't that sound eerily like our modern scientists, pushing the boundaries of technology to extract truths from the cosmos? Consider how the mead was said to distill the blood of Kvasir, a being born from the collective wisdom of the gods. Today's astronomical breakthroughs are similarly forged from the pooled knowledge of generations. Telescopes like James Webb, built upon centuries of optics, spectroscopy, and engineering, distilling starlight into data. Each exoplanet discovered is a drop of that cosmic mead, a revelation wrested from the void through ingenuity and grit. Take the discovery of water vapor in the atmosphere of K218b, a feat that would have seemed like magic to the Norse, yet is rooted in the same relentless curiosity that drove Odin to drink from Mimir's well. Yet the mead's power wasn't just in its origin, it was in its transformation. Those who drank it didn't merely gain knowledge, they became conduits for it, their words shaping the world. Science operates the same way. When astronomers decode the light from TRAPPIST-1's planets, they're not just collecting data, they're rewriting humanity's understanding of habitable zones, turning raw numbers into narratives about life's potential. The mead was guarded by the giant's daughter, Gunnlod, who wept as Odin stole it. Today's discoveries, too, are hard-won, often born from years of failed hypotheses and recalibrated instruments, the weeping before the breakthrough. And here's the twist, the mead wasn't meant to be hoarded. Odin shared it, spilling drops across Midgard so mortals could taste inspiration. Modern science thrives on the same principle: open access databases, published findings, and missions like Hubble's legacy archives, ensuring every curious mind can sip from the well of discovery. When a high school student analyzes Kepler data to find a new exoplanet, or when citizen scientists flag atmospheric anomalies in TESS observations, they're partaking in Odin's gift, proving that the mead's magic wasn't in its scarcity, but in its ability to ignite minds. Perhaps the most striking parallel lies in the mead's duality. It could bless or curse, elevating poets or driving unprepared drinkers mad. Science, too, carries this weight. The same tools that reveal Earth like exoplanets could one day expose our own world's fragility. The knowledge that fuels wonder also forces us to confront cosmic insignificance. But like the skalds of old, we press on, lured by the promise of that next intoxicating revelation. So the next time you hear about a planet cloaked in auroras or an ocean world glowing in the dark, remember, the mead still flows. We're just drinking from a different cup. The universe has a way of turning myth into reality, especially when it comes to exoplanets. Take Kelt 9b, a planet so scorching hot its atmosphere glows like the forges of Muspelheim, with temperatures soaring over 4,000 degrees Celsius. This isn't just a fiery world, it's a cosmic inferno where molecules are ripped apart and reassembled under extreme heat, much like the primordial chaos the Norse believed birthed the giants. Then there's GJ 1214b, a steamy waterworld cloaked in thick perpetual mist, its surface likely drowned under global oceans. If Niflheim had a celestial cousin, this would be it, a realm where the air itself feels heavy with moisture and the boundaries between sea and sky blur into oblivion. But the echoes don't stop there. Consider WASP 12b, a planet being devoured by its own star, its atmosphere stretched into a teardrop of glowing gas as it spirals toward destruction. It's a haunting parallel to Fenrir's inevitable escape at Ragnarok, where the wolf's gaping maw swallows the sun. Even the way this exoplanet's material trails into space mirrors the serpents of Norse myth, their coils dripping venom into the cosmic void. On the opposite end of the spectrum, planets like Ogle 2005 BLG 390 LB drift in eternal frozen silence, their surfaces colder than the darkest reaches of Helheim, where not even starlight can penetrate the gloom. The real shock isn't just that these worlds exist, it's how specific the Norse descriptions were. They didn't just vaguely imagine hot or cold realms. They painted vivid scenes of molten rivers, frozen wastelands, and unstable borders between realms, each detail now reflected in exoplanet data. Lava worlds like 55 Cancri, where entire hemispheres melt into magma oceans under relentless stellar heat, could have been lifted straight from the saga's depictions of Muspelheim's borderlands. Even the diamond planet PSRJ 1719-1438b, an ultra-dense world crystallized under crushing pressure, feels like something the dwarves of Svartalfheim might have crafted in their underground forges. What's fascinating is how these discoveries challenge our assumptions about ancient myths. The Norse didn't have telescopes, but they had something just as powerful: the ability to observe patterns in nature and extrapolate them into cosmic truths. When they described Yggdrasil's roots tapping into realms of fire and ice, they were intuiting the universe's habit of balancing extremes. Modern astronomy confirms this. For every hellish, hot Jupiter, there's a frozen rogue drifting untethered through the dark. The myths weren't flights of fancy. They were blueprints scratched onto parchment by minds that understood the cosmos's love of duality. And perhaps most compelling of all is how these exoplanets interact with their environments, just as the Nine Realms influenced one another in Norse lore. The tidal forces wrenching WASP 76b into a teardrop, the stellar winds stripping HD 209,458b's atmosphere into a comet-like tail, these aren't isolated events. They're dynamic, interconnected processes, a celestial game of cause and effect the Vikings encoded in tales of gods and giants clashing across the branches of Yggdrasil. The closer we look, the more the line between myth and science blurs, leaving us to wonder: did the Norse see further than we ever imagined, or is the universe simply repeating its favorite stories? Science is now catching up to the Norse imagination in ways that would make Odin himself nod in grim satisfaction. Recent exoplanet discoveries aren't just vaguely reminiscent of the Nine Realms, they're matching mythic descriptions with unnerving precision. Take the lava world K218b, where temperatures exceed 2,000 degrees Celsius, turning silicate rock into airborne vapor. This isn't just a hot planet, it's Muspelheim incarnate, a realm where, as the sagas warned, rivers flow with knives and the air itself burns. Even the planet's erratic orbit, swinging violently close to its star before lurching away, mirrors the Norse vision of fire giants testing the boundaries of their realm. But the validation goes deeper than surface comparisons. When the Proxima Centauri system revealed an Earth-sized exoplanet orbiting in the habitable zone, it wasn't just a scientific milestone. It echoed the Norse concept of Midgard as a sheltered middle ground balanced between extremes. Spectroscopy data from planets like GJ486b, with its potential magma oceans beneath a thin crust, aligns disturbingly well with descriptions of Svartalfheim's subterranean forges, where dark elves hammered metal in glowing caverns. Even the diamond rain, theorized to fall on Neptune and Uranus, finds a precursor in the dwarven treasures of Norse myth, gems forged under crushing pressure. What's most compelling is how these parallels extend to planetary systems as a whole. The TRAPPIST-1 system, with its 7 tightly packed worlds, mirrors Yggdrasil's interconnected realms, each planet influencing its neighbors through gravitational resonances, just as the roots of the world tree tied each realm's fate to the others. When astronomers discovered that the star Vega likely ejected a massive exoplanet into interstellar space, it recalled the Norse tale of Loki's monstrous offspring, Fenrir and Jormungandr, cast out to the cosmic margins. These aren't superficial similarities, their structural echoes suggesting ancient observers recognized patterns in nature that modern instrumentation is only now quantifying. Consider the case of rogue planets, free-floating worlds untethered to any star. Estimates suggest there could be billions drifting through our galaxy alone, invisible to traditional detection methods. The Norse myths described Niflheim as a realm detached from the cosmic order, a frozen exile adrift in the void. The recent discovery of the rogue planet CFPD Sir 2149-0403, with its aurora-lit skies and probable ice-shrouded surface, reads like a page straight from the prose Edda. Even the planet's estimated age, around 50 million years, barely a blink in cosmic terms, parallels the Norse view of Niflheim as a primordial wasteland older than time itself. The kicker: some of these scientific validations are emerging from unexpected disciplines. Paleoclimatologists studying Viking Age ice cores have found evidence that Norse seafarers may have used atmospheric refraction phenomena like the rare sky mirror effect to navigate. This suggests they weren't just storytellers but meticulous observers of celestial mechanics, capable of extrapolating planetary conditions from atmospheric distortions. When modern telescopes confirmed the existence of exoplanets with metallic clouds, like LTT 9779b, it raised a tantalizing question. Did Norse descriptions of Asgard's golden walls and gleaming bridges originate from observed astronomical phenomena, like the light-bending properties of exoplanetary atmospheres? This convergence of myth and data challenges our assumptions about how ancient cultures processed the cosmos. The Vikings didn't need spectrometers to intuit that lava worlds and ice planets represented cosmic extremes. Their own volcanic landscapes and glacial fjords taught them nature thrives on polarity. Their myths weren't primitive guesses but sophisticated models, compressing universal truths into narrative shorthand. As the James Webb Telescope unveils exoplanetary atmospheres swirling with vaporized rock or supercritical oceans, we're not just collecting data, we're deciphering a code our ancestors may have embedded in their stories millennia ago. The real mystery isn't whether they knew more than we realized, it's how much deeper their insights might go. Of course, the most skeptical among us might shrug off these cosmic parallels as pure coincidence, just a lucky roll of the mythological dice. After all, the Norse were storytellers, not astrophysicists. Couldn't their vivid descriptions of fire and ice realms simply be poetic exaggerations of earthly volcanoes and glaciers? It's a fair challenge. Human imagination tends to mirror the natural world, and when you've got a culture living in the shadow of erupting geysers and frozen fjords, it's no surprise their myths would lean into extremes. But here's where the coincidence argument starts to crack. The Norse didn't just describe generic, hot, and cold places, they envisioned entire planetary systems, with realms that interacted dynamically, their fates intertwined like gravity-bound exoplanets. Take their depiction of Muspelheim's sparks clashing with Niflheim's ice to birth life, a process eerily similar to how planetary formation begins in protoplanetary disks, where heat and cold collide to forge worlds. Or consider Yggdrasil's roots, each tapping into distinct realms, much like how star systems host planets with radically different environments. These aren't broad strokes, they're startlingly specific. Then there's the statistical improbability, the sheer diversity of exoplanets we've discovered. Lava worlds, ice giants, diamond planets matches Norse cosmology with uncanny precision. If their myths were just lucky guesses, why do their realms align so neatly with scientifically confirmed planetary types? It's like tossing a handful of sand into the wind and watching it spell out the periodic table. Possible, but staggeringly unlikely. Perhaps the most compelling counter to the coincidence theory lies in the Vikings' own navigational prowess. These were people who crossed oceans using stars, weather patterns, and even the color of waves to guide them. Their myths often doubled as celestial maps, like the tale of Orvandil's frozen toe becoming a star, possibly encoding supernova observations. If they could track solstices and predict eclipses, is it so far-fetched to think they might have noticed planetary patterns, even subconsciously? That said, we should be wary of overinterpretation. The sagas weren't textbooks, and assigning modern scientific labels to every myth risks stripping them of their cultural richness. Maybe the Nine Realms were never meant to be literal planets, but as metaphors for cosmic balance, they're astonishingly prescient. The universe loves duality, chaos and order, creation and destruction, fire and ice. The Norse didn't need telescopes to sense that rhythm, they felt it in their bones. So where does that leave us? Somewhere between coincidence and hidden knowledge, a space where intuition and observation blur. Whether by chance or insight, the Norse myths mapped a universe we're only now beginning to explore in earnest. And if nothing else, their stories remind us that science and wonder don't have to be enemies. Sometimes the oldest tales hold the newest truths. From fiery Muspelheim to the frozen wastes of Niflheim, the Nine Realms of Norse mythology don't just resemble exoplanets, they practically blueprint them. This isn't mere fantasy echoing science. It's as if the Vikings peered across time with a god's eye view, sketching celestial truths they couldn't possibly have known. Lava planets where metal vaporizes into crimson skies, the sagas called them first. Rogue worlds adrift in eternal night, Helheim's mists foreshadowed their gloom. Even Yggdrasil's cosmic architecture, realms stacked like branches in a tree, finds its mirror in orbital mechanics, where gravity weaves planets into delicate, resonant dances around their stars. But the real magic lies in how these myths interact. The Norse didn't just catalogue realms, they wove them into a dynamic tapestry where fire and ice clashed to birth life, where bridges like Bifrost thrummed with energy between worlds. Modern astronomy reveals the same choreography. Exoplanets tugging at their stars, atmospheres bleeding into space, molten worlds and frozen outcasts, all bound by invisible threads of gravity. When NASA models show how TRAPPIST-17 planets gravitationally shepherd one another into harmony, we're watching Yggdrasil's roots pulse with the old gods' whispered prophecies. So what does this mean for us? Maybe the Norse were more than storytellers, maybe they were the first astrophysicists, reading the universe's patterns in the only language they had, metaphor. Their myths remind us that science and wonder aren't opposites, they're two sides of the same coin. Every time a telescope unveils a new world, a diamond planet here, a steam-shrouded ocean world there, we're not just filling databases. We're walking paths the Vikings mapped long ago, their sagas glowing like celestial breadcrumbs in the dark. This is your invitation to keep looking. If Norse myths could hold such startling truths, what other cosmic secrets might be hiding in humanity's oldest stories? Grab a telescope, crack open a saga, and join the hunt. The universe has always been speaking through fire, ice, and the echoes of ancient voices. The real question is, are